This is video number 1, and it's the little robot computer. Now, if you just stumbled onto this by accident, go to a website called readyforrobotics.com, and that will explain what's going on here. But the objective of this series of videos is to explain how the computer, a modern digital computer, actually works. And the rationale for this, as I said, is explained on this site. And by the way, the post is called First Video. So what I want you to do is to grab a piece of paper and draw with me. And don't worry about making anything beautiful. This won't be beautiful either, but it will. You will see how this works. So grab a piece of paper and we're going to draw a room. And we'll start over here and we come all the way down, come back. And I'm going to leave a couple of spaces or openings for input and output. Call this one in and this one out. And inside this room, we have a few things. On the right-hand side, which will represent the storage of a computer, we have 100 mailboxes, numbered 0 to 99. And those numbers can be considered the addresses of those mailboxes. Inside, we have a little robot, and I'll draw it like this. And the robot, we'll give him an R, why not? And he does a whole bunch of different things, but he's programmed to do very specific things, cannot think on his own or make any kinds of judgments. We have a register, which we will call the A register, or accumulator. And I'll break it into 3 pieces because the data that goes in there is 3. So there'll be 3 digits. So this is a 3-digit computer. Now we also have another register at the bottom. Here we'll call the program counter, or PC. And it has 2 digits. And the reason is that these 2 digits correspond to the addresses of these mailboxes here. And I also want you to put a little lever here, and we'll call that the +1 lever. And I'll explain to you in a minute why that is. Now I'm going to put a couple of other things. We have to start and tell the robot when to start, so we have a little button on the outside here which says start. And there's a little light there, so when the robot sees the light, it starts. And I will explain what happens when it starts. Another little button here for the robot, which I'm going to label question mark, because one of the things that happens is that the program will tell the robot to request input, and the input is here, and if there's nothing there, it asks for it. And you've seen this on your programs where you have a form and it says enter your name, that sort of thing. If your name's already there, then it doesn't ask. And we also have a when something goes wrong or the program ends button, so that we can know when the robot's finished. And here we'll draw it this way. And here we have a light, and this is the stop. We'll call it stop. Okay. Now the question is, how does all this work? Now the next thing we want to explain is, what can the robot do? The robot does really 3 things. 1, it fetches an instruction. As we call it, the fetch cycle. It fetches an instruction that's put into, it's also a 3-digit instruction that is sitting in one of these mailboxes. Second thing it does, it decodes that instruction, and I'll explain how that works. And once the instruction is decoded, it then executes. And this goes on and on and on until actually it sees a 0 in the one of the mailboxes, and when it sees a 0, it knows it's finished, and it comes over and pushes a stop button, and then you see the light come on, and we know the program is over. We probably know the program's over anyway because there'll be some output or something that we have requested. Now I want to talk about the instructions or the commands that this computer has in its own language. And first of all, let's talk about moving data. We need to get data from the input into the A register, and that command has code 901. So just remember that. There's also a corresponding command to get the data out of the A register, which is 902. Then we have commands to store data from A into one of these mailboxes, and that is a 3, and I'll say XX because we don't know it can be any of the mailboxes. It can be 300, it could be 399, it could be 350, whatever. And then there's also a corresponding command to load the data from the mailboxes, and that's 5XX. So 522 would mean take whatever is in 22 and put it into the A register. So these are the commands that you will use to move data around. Now that's all you're doing. Now notice there are no commands in this computer to move from the input to the mailbox directly or back out. You always have to go through the accumulator register. Actually, the very early computers, and one I programmed when I was in college, actually had an accumulator, one. Now typically the computers have many accumulators, and there's all sorts of commands to go back and forth, but the principle is still the same. It works, the machine works like this. Now I'm going to give, there are other commands in this language, but one I'm going to give you right now is called add. It's 1XX, and what that says is I want the robot to take whatever is in mailbox XX and add it to what is in the accumulator and put it in and replace it what is in the computer. So I can say that what you'll have is that we will take the contents of whatever the memory location is, one of these mailboxes, plus whatever is the content of A, and it will replace, and we'll put that back in A. Now you'll notice that I'm a little sloppy sometimes when I talk about take a number from one place and put it to the other. Typically in a computer, when you take a number from one place to the next, you don't take it, you just take a copy. So if I say move like 350, I don't destroy what was in location 50. I just take a copy of that and put it in the accumulator. Now when I put it in the accumulator, if there was something there, I would destroy that. So it's pretty commonsensical, but almost everything works this way. When you read something into a register or move it from one register to the other, you don't really move it, you just take a copy of it. Now that language tends to be a little sloppy, but anyway, that's how that part goes. Now I'm going to jump ahead a little bit, and I know this has gone pretty fast, but all you have to do is stop the video and go back and so forth. And by now I think you should have pretty much written on your paper what we have here, but I'm going to give you a program that we're going to put into the computer. And I'm going to start in location 0, so in location 00, I'm going to put the command 901. And in 01, I'm going to put 390. In 02, I'm going to put 901. And in 03 mailbox, I'm going to put 190. And in mailbox 4, I'm going to put 902. Now the rest of them, 05, they all have zeros. And in fact, when we initialize the computer, everything is 0. The PC is 0, the A is 0, and all the mailboxes are set to 0. But I'm going to then go in and put 901, 390, 901, 190, 902 in. Now, stop the video right now, and what do you think that program will do? Now, before I take you through this program, let me describe a little more carefully what happens with the computer here. With the fetch cycle, what the computer does, I think what the robot does is it goes down to the PC, it looks at the number. Now what it's going to see at the beginning is 0, 0. It sees it 0, 0. It sees it, it remembers it, and it pushes the +1 button, so this now turns to 0, 1. It then goes to the 0, 0, or whatever was here, and it looks and it records what the command is. In this case, that'd be 901. It then decodes it. That's the next thing. So when it decodes the program, these are all three numbers, and the first digit is really the command and the other is the address. Now the only exception is this 901 and 902 really are input and output. But the 3, the 5, and you'll find there'll be some other ones, some branch instructions. It looks at that number and sees if that's proper, and then it will do some certain things, but it will know what to do. The next thing it does is then it executes the instruction. So let's look at what happens when it takes this command. The first thing is, let's just assume, for example, that we put in 32 as a number. We put it in the input over here, and the robot sees the 901, so it will take 32 and it will move that to the A register. So the content of the A register will now have 32 in it. So it's got 32, or 032 if you want, because there are only 3 digits allowed. Now 390, what does that say? 390, it decodes it. It says 3 is a store, and it's going to stick it in mailbox number 90. So what happens is mailbox number 90 will hold 32, because that was what was in the A register. Now the A register still stays the same. There's still 32 in there. Now 901, I'm going to put it's requesting input, so the robot runs over. And remember, each time it keeps pushing this number +1 button, so this program counter starts to advance by 1 each time. So that when it comes the next time, it will go to the next instruction. So it sees another 901. Let's say we put in 5. So 5 goes into the A register. And remember, when I put brackets around something, that means this is the contents. So the A holds this 5. Now we have 190. Now what is 190? Well, it decodes the 1 and sees the 1, and the 1 says, oh, add whatever is 90 to the A. So we take the contents of A plus what was in 90, and that goes into A, which in this case will be the sum of 32 and 5, which will be 37 if my arithmetic is still good. And the next thing it does, it'll go through and it looks at 902. It's going to output it. Output A, so it outputs 37, and there's 37 sitting here in this output tray. Now, the robot doesn't know it's finished. So it goes on, it looks at the PC, punches it, goes back, and it sees the 0. And when it sees the 0, 0, this command says, I'm done. So it comes over, pushes a stop button, this thing lights up, and we're finished. Okay, I've put a new screen up here, and this is the program that we just wrote. And you've figured it out that this is to add a couple of numbers. Okay, I'm just going to leave this video, but I want you to do your own program, and I want you to input 3 numbers, add them, and output the sum. And I'll take you through that in the next video, but make sure that you do understand the logic that this robot goes through when it computes these numbers. See you next time.